Hello, I'm Gabriela Godinho. I'm a doctoral student in environmental sciences at the Federal University of Western Pará. I'm also a PhD student in atmospheric physics at the University of Reunion in Reunion, France. Today I'll explain to you some of the results of the first article published that came out of my thesis research. The title of the article is Solar Ultraviolet Radiation Temporal Variability Analysis from 2 years of continuous observation in an Amazonian city of Brazil. It is part of my thesis project, which is entitled Time-Space Variability of Solar Ultraviolet Radiation Between the Amazon Rainforest and Antarctica. So first, I want to explain to you the importance of studying ultraviolet radiation. Why study ultraviolet radiation? You probably have heard at some point someone telling you that you need to wear sunscreen, that you need to protect yourself better from the sun around 10 a.m. and 4 p.m. Also that sometimes you need to expose yourself to the sun because it's good for your health. And all these well-known recommendations are based on the harms and benefits of ultraviolet radiation. And what is this? Ultraviolet radiation are electromagnetic waves with wavelengths from 100 and 400 nanometers that comprise a small fraction, about 5% of the energy emitted by the sun that reaches the terrestrial surface. This spectrum of solar radiation has direct effects on human health, on terrestrial and aquatic ecosystems, and on the degradation of materials. So ultraviolet radiation can be both beneficial and harmful to ecosystems. As an example of benefits, ultraviolet radiation can be useful in the treatment of systemic autoimmune diseases such as multiple sclerosis, also in the prevention of myopia, and recently research suggests that adequate exposure to UVR can be substantial in reducing mortality. On the other hand, regarding the damage caused to the ecosystems by the ultraviolet radiation, both increased intensity and time of exposure to UVR decrease the photosynthetic activity of some crops, such as radish, soybean, and some pine trees. Also, regarding aquatic ecosystems, changing ultraviolet radiation exposure alters the structure of these ecosystems, enhance their ecosystem service like water quality and fishery productivity in regionally specific ways. And it's also proven that larvae of many commercially important fish are sensitive to ultraviolet radiation, with fecundity, growth, and survival affected. Concerning to us humans, the two major health problems related to ultraviolet radiation are skin cancer and cataracts. Disease related to the accumulation of exposure to UVR, like skin cancer and cataracts and others, are largely preventable when there is adequate sun protection. So, given the need for this type of information, the World Health Organization, along other organizations, released the Ultraviolet Index. The Ultraviolet Index informs the amount of ultraviolet radiation that reaches the surface. It has value range from 1 to 11 or more. It is subdivided in 5 categories from low to extreme, and has specific orientations for sun protection at each level. The higher the UV index, the higher the health risk. So ultraviolet radiation incident on the surface is not uniform, it varies. Its variability depends on a lot of factors. It depends, for example, on the solar cycle. It depends on the Earth variation, the variation of the Earth's position relative to the Sun. It depends on atmospheric, geographic, and temporal parameters, which are influenced by solar angle of incoming radiation, by latitude and longitude, by clouds, albedo, aerosols, and another atmospheric constituents. So ultraviolet radiation can be both beneficial and harmful, is influenced by a lot of factors, and how is it monitored? It can be monitored by both by ground-based and satellite instruments. Unfortunately, due to the high costs and due to the need of specialized skilled maintenance personnel, most of the countries in the world have just a few places to monitor ultraviolet radiation, which makes it really hard to extrapolate the studies to all populated areas. So the only way to continually monitor ultraviolet radiation in a global level is through satellite retrievals, although ground-based measurements are more accurate than satellite retrievals. In Brazil, for example, there's a few places monitored, and of the few published studies, most of them are from the southeast, northeast, and south, respectively. The situation is even worse. The lack of ground-based data in study is even worse when it comes to the Brazilian Amazon, with just 2 studies published, one for the city of Maitá in the state of Amazonas, and one from the city of Santarém in the state of Pará, which was our study. Both analyzing data just for the year of 2019 and 2020. So, all this information that I just presented and more that I don't have time to explain here, they support the importance of studying ultraviolet radiation. And based on this, the question that guides my project is, what is the time-space variability of ultraviolet radiation incident between the Amazon forest and Antarctica? We don't want to know how the ultraviolet radiation varies just in Santarém. We want to know how it varies in Northeast, in the Southeast, in the South, and how it varies until the Antarctic station in Antarctica. And this main question englobes another specific question, as for example, these 3 ones, which guided the first article. Since there were no studies published related or using ground-based measurements for the city of Santarém, in this study, we wanted to understand what is the temporal variability of surface UVR in Santarém, how does seasonality influence the intensity of surface UVR in Santarém, and how does surface UVR varies without the influence of cloud cover in Santarém, Pará. You can have access to this article. You just need to scan this QR code right here. So for this, we used ground-based measurement in Santarém. Santarém is a medium-sized city located in the state of Pará, in north of Brazil. The climate in Santarém is humid, equatorial, with a well-defined dry and wet season. It also presents a small variability in air temperature, wind speed, humidity, and atmospheric pressure, due to be located in a low latitude near to the equator. The objective of this article was to characterize, through the obtained UVR time series, the temporal variability in different time scales, daily, monthly, and seasonal, and in different cloud cover conditions, in clear sky and our sky conditions. The sensor was installed at a height of 18 meters in a tower located in the UFOPA campus in Santarém. It was used a UVR sensor, model SU100SS. It has a spectral range that goes from 250 to 400 nanometers. That comprises the entire UVA and UVB. The period of study started in April 2019 and went until November 2020. The measurements were continuous, with a sampling frequency of 1 Hz in a watts per square meter unit. Cloud cover data were obtained from metadata from the International Airport of Santarém, downloaded for free through the HedMets application. In this first step, in order to understand how ultraviolet radiation varies without the influence of cloud, the areas corresponding to clear sky condition, KVOC and field, were analyzed, as well as the hours corresponding to all sky conditions. Also, in this work, we used the dry and the rainy season divisions. Santarém has a period known as a rainy period, which generally goes from January to June, and a period called dry period, which usually starts in July and goes until December. In the rainy period, there are more precipitation, more cloud coverage, and in the dry season or dry period, the precipitation falls, also the cloud coverage. So the division adopted in this work are based on these two conditions. Here are some of the results. Here is the UVR hourly daily series in all sky and in clear sky conditions. Over the 731 days corresponding to the years of 2019 and 2020, the UVR obtained time series contains 443 days of data. Of these days, 333 had some hour of clear sky condition. It's possible to see through this daily hour variability that the UVR variation presented small variation throughout the year. Also that the highest UVR intensity were around local solar noon. These results were expected since Santarém is located at a low latitude, therefore solar zenith angle is lower, which induces higher UVR, smaller amplitude between the seasons, also a very low photoperiod variation. Here it is the UVR month average in both sky conditions. Regarding the medians and the average, the UVR was higher, especially between June and October. These months are predominantly months of the dry season, when there is less precipitation, more hours of clear sky condition, and more aerosol due to the burning season in the Amazon region. Regarding in all sky conditions, although the first quartile, the median, the average, and the third quartiles were higher during the dry season month, the maximums were higher in November, April, and January, respectively, in December. And April and January, they are months of the rainy season, and December is a month of, according to some authors, is a month of transition, with the cloud cover precipitation starting to increase again. Therefore, it seems that cloud cover plays an important role on the variability of surface UVR, mostly by attenuating, but sometimes by increasing the intensity of the radiation that reaches the surface, as expected in the presence of the cumulus or deep cirrus clouds. Regarding the clear sky condition, the fact that some months of the rain period presented higher values than months of the dry season can be explained by the fact that in the rainy season are less aerosols in the atmosphere, therefore less attenuation of the ultraviolet radiation. In addition, the sun passes through the zenith of Santarém about twice a year during the equinox. There is one equinox around March and another around September, and this is when the ultraviolet radiation, the higher ultraviolet radiation is expected. Unfortunately, because of the lack of data, we don't have in this work we didn't have how to prove to confirm the annual influence of the annual cycle in the ultraviolet radiation, as expected with the one peak during the March equinox and another during the September equinox. Here we have the ultraviolet variability according to the period. These results reinforce the previous one. it's possible to see that both in our sky and clear sky conditions, the dry period presented higher average, median, and maximum compared to the rainy season. And this can be, despite the small difference, it was higher during the dry season. And it can be explained by the latitudes of Santarém. Also, this small amplitude and the higher values found in the dry period can be explained by the presence of cloud cover, which is higher in the rainy period, therefore with more attenuation of ultraviolet radiation, and smaller in the dry period with less attenuation. Unfortunately, because of the lack of the 2 months, February and March, these results, they may not represent precisely the period variability in Santarém, but it's is a good indicator of how this variability must be in this Amazonian site. So in summary, the ultraviolet radiation incident in the surface in Santarém has little variation over the course of the year. It also presents, it's also higher during the dry season than in the rainy season. And cloud cover seems to play an important role in the variability of the ultraviolet radiation. Now we need to continue monitoring it, and we need to extend the monitoring to another atmospheric parameters such as aerosols and cloud cover, ozone, and we are also now studying the ultraviolet index. We are using satellites and ground-based data, like satellites from instruments like from OMAI, GOM2, and in the future PhotoProm, and we are gathering ground-based data with collaborators of different cities, like from Santa Maria, Itajubá, Natal, and other cities, to continue the analysis of ultraviolet radiation and better understand its dynamics between the Amazon rainforest and Antarctica. Thank you. Obrigada.